what we have discussed is, we have discussed about floating and sinking. So let's do a sort of revision. In the floating and sinking, what we have learned is, for an object to float or to sink, what matters is the density of the object. Okay, if the density of the object which is at the top is more, it will sink. If the density of the object which is at the top is less, then it will float. So with that knowledge, we'll move forward to the next topic, which is law of flotation. So according to law of flotation, before starting law of flotation, I'll just tell you about physical quantity termed as weight. It's a very confusing quantity because people kind of compare this with the mass of the body. But weight is not actually the mass. Okay, weight is mass multiplied by gravitational force or the gravity of the earth. So it is mass multiplied by gravity of the earth. It is actually a type of force. Okay, weight is a type of force which we are putting in the surface of the earth. So we have to take that concept in our mind and move forward with the topic. So first of all, I'll give you an example. When a body floats in a liquid, okay, when any object, if there is a liquid, when an object, when it floats in a liquid, means at the top of the surface, not going down, but at the top of the surface, when it is floating at the top of the surface, the weight of the liquid displaced by it is immersed part is equal to the total weight of the body. So now, when you look at this image over here, there is liquid, on top there is an object. So this object is applying some force towards the liquid. That is known as the weight of the body. So if the weight is more, that means if the force is more, this object will go down. If the weight is less, it will float. And it will float on the surface when the weight is zero. No force at all. Weight zero means no force. Okay, this is first one. Now second, if this object sinks a little, okay, if it sinks a little, floats a little, means half of the body is inside the liquid, half is above. So if any object, if you dip in the liquid, what happens is the level of the liquid will increase. This level will increase by some height. Okay, there is some sort of rise in the level of the liquid or water. So the amount of level which is increased, okay, the amount of level which is increased is equal to the weight of this object. So it is liquid which is displaced by what? Displaced by the object is equal to weight of the body. Okay, so if this total object, if this total body goes inside, okay, that means weight is more obviously, because of the weight only it is going down, weight is more than that of the weight of the liquid. It means force of the liquid. So if it's going down, that means the object is sinking. Now if total object goes down, what happens? A little more amount of liquid the level will increase. The more amount of liquid will be displaced. So the liquid displaced is equal to the weight of the object. This is the law of flotation. In simple words, liquid displaced by the object is equal to weight of the body, the weight of the object. So now, with this, there is one activity in the book. I'll just explain the activity. Okay, the activity is take two identical small blocks of wood. Now, the object which is there is same. In two different vessels, in one there is water. Okay. In another one, okay, in another vessel, we have glycerin. Okay, another one we have glycerin, in one we have water. So first what we have to know is density of glycerin is more than the density of water. If you take glycerin in your hand and water, what is thicker? Glycerin is obviously thicker than water. So glycerin has more density than water. Now, next what we do is we put a small piece of wood over here at the top of your surface. Okay, wood is same. The density of wood in both is same. So, in what we can observe from here is, in water what happens is it will sink a little, not totally. Whole of the wood will not sink. Only half of the body will go inside the water. Half will remain above the water. Now, in the case of glycerin, and wood, a very small portion of body will go inside, the rest will remain at the top. So the difference in both the images, what we can see is, in the first one, half of the body is inside the water, half above. But in glycerin, only a small portion of the object is inside the liquid. Other than that, it is at the top. So from here, what we can conclude is, the density of wood is less than the density of water. In this part, density of this wood is less than the density of water. That is why it is at the top. And even in this case, density of this wood is less than the density of glycerin. That is why it is remaining at the top. This is first thing. If it is sinking, we should understand that whichever object is at the top, whichever object is at the top has more density than the object which is there at the bottom. This is the first conclusion. Second one is the density of glycerin. We can see that a lesser amount of object is going inside. So density of glycerin is more than the density of water. Okay, this is the second conclusion. So from here, the conclusion is given in the book, page number 28. You can follow from that activity itself. So from here, what we have understood is, whichever has more density will remain at the bottom, whichever has less density remains at the top. And the law of flotation is the amount of liquid displaced by the object. Okay, the amount of liquid which is displaced. Whenever we put something in water, the level of the water will rise. The amount of increase in the height of the water or the level is actually equal to the weight of that object. Okay, if object is heavier, more amount of water will be displaced. If the object is lighter, lesser amount of water will be displaced. Example can be, if a fat person goes into the pool of water, a very little more amount of level of water will rise, whereas if a thinner person goes inside the water, a little level of water will rise. So there are some few examples of flotation or applications of flotation. I'll just explain that. First one is flotation of an iron sheet. What we know is, if you have a small nail and you put it in a bucket of water, the nail will obviously go down because the iron has more density than that of water. Simple logic. But why does a ship, which is also made up of iron, does not sink? It floats in the top of water, it floats in the sea or in the ocean. So in that case, the reason for a nail to sink is if the density of iron nail is greater than that of water. But what we have another one is a ship. So in a river, if we have a ship which is made up of, looks like a boat, but again it could be a ship. If we have a ship made up of iron, then why does this not sink, whereas an iron nail made up of same material sinks? So what you have to understand over here is, the density of only iron does not matter. Also what matters is, over here what is there inside a ship? It is vacuum. Over here it is empty. Empty means not totally empty, it has air. So air also has some sort of density. So the density of air, density of iron, when we combine the both, okay, when we take the average, combining both means taking the average, when we combine the both, then the combination of the density of iron as well as air makes it lesser dense than that of water. So the density of whole ship will be less than that of water. That is why it doesn't sink. I hope it is clear. There are few more examples in the blue book, such as flotation of man. You can read it by yourself. There are few examples. For example, submarines are there. Whale is there. Whale is a sea animal which float sinks, it depends on the wish of the whale. So whenever a whale has to go above the water level, then what it does is, it has an organ known as swim bladder. Okay, it has an organ known as swim bladder. So in that swim bladder, what it does is, it takes all the air from outside. Okay, it takes the air. After taking the air inside, what happens is, the density of the air, the density of the whale becomes less than the density of water. So it will move at the top surface of the ocean. It doesn't sink. Okay. Another example is balloons. Whenever we put air inside the balloon, the air which we put inside is actually helium and hydrogen, which has less density than that of air which we breathe. So because of that lighter air, it goes above from the Earth's surface. It will fly up. So these are the few examples. Now with this topic, I have come to an end to this chapter. Please do solve the objective questions and all, because for your next test, which is coming on 3rd of May, I'll be giving you these questions from both the chapters, chapter 1 and chapter 2, and the test will be conducted via TeachMeet. So please do enroll yourself in TeachMeet and be available over there on 3rd of May. So the syllabus will be this first and second chapter. Okay. So this much for today. In the next class, I'll start a new chapter.